Why do humans have different skin colors? Look around you. Dark skin, light skin, every shade of brown, olive, and copper in between. Every one of those people is the same species. And every one of them traces back to Africa. So how did one African population produce every human skin tone on Earth? The answer is sunlight, genetics, and thousands of generations of migration. Welcome back to BTS Africa Media, where we go behind the scenes of society to unlock what remains hidden or forgotten. What is the original human color? Rewind roughly 300,000 years to the discovery of the Jebel Irhoud fossils in Morocco, the oldest known Homo sapiens remains. During this time, there were no nations or ethnic categories, just early humans living across Africa, most of them close to the equator, where UV radiation is some of the most intense on the planet. Skin carries a pigment called melanin. It absorbs and scatters ultraviolet radiation, protecting skin cells from damage and preventing UV light from breaking down folate, a nutrient critical to reproduction and fetal development. Under Africa's intense sun, high melanin levels were a serious survival advantage. Generation after generation, people with more protection against UV damage did better. Over enough time, dark, melanin-rich skin became the default across the populations living there. That's an adaptation, tuned to a specific environment. Then humans began migrating away from that environment. And that's where the story gets a lot more interesting. Out of Africa is a prehistoric movement of early Homo sapiens migrating out of the African continent to populate the rest of the world. Starting roughly 60,000 to 80,000 years ago, groups of humans began leaving Africa, into the Middle East, across Asia, into Europe, eventually reaching Australia and the Americas. Driven by survival, early humans followed the rhythms of a changing planet across generations. As the Earth's climate fluctuated, curiosity and the search for fresh food pushed families beyond the horizons they knew. Every new region brought a different climate, different food sources, and critically, a different dose of ultraviolet radiation. The farther a population moved from the equator, the weaker and more seasonal their UV exposure became. Near the equator, heavy melanin was protective. Farther from it, that same protection started blocking too much of the UV needed for vitamin D. The evolutionary math flipped. Over thousands of generations, natural selection began to trigger lighter pigmentation in populations living at higher latitudes. The environment changed, so the selective pressure changed with it. Ancient DNA tells a story that shatters our simple assumptions about the past. Early hunter-gatherers walked under overcast northern skies, bearing a striking physical signature: deep dark skin paired with striking light-colored eyes. They were hunters like Cheddarman in the forests of Britain and Labrana in the hills of Spain. These are people whose genetic makeup exists nowhere in the world today, but was once the norm across a continent. Change did not happen overnight, nor did it happen in a single place. The transformation of European skin tone was a slow, multi-directional wave, set in motion by a shift in how humans lived. When agriculturalists from Anatolia journeyed into Europe around 8,000 years ago, they brought wheat, barley, and new ways of life. But as farming replaced hunting, diets shifted away from fish and wild game, foods rich in vitamin D. With less nutrient intake from their meals, a new evolutionary pressure emerged. Body chemistry had to adapt to synthesize vitamin D directly from the sunlight. Light pigmentation variants, once rare, began to offer a crucial survival advantage. Generations passed, and another wave arrived. Pastoral nomads swept in from eastern Eurasia, blending their genes and culture with the populations already there. Through movement, intermixing, and thousands of years of gradual genetic drift, lighter skin gradually became common across the continent. There was no single moment when a population suddenly became light-skinned. Evolution doesn't work from one master blueprint. It works with whatever genetic variation already exists in a population, and adapts that raw material generation by generation. North African populations show different pigmentation patterns than West African populations. South Asian populations differ genetically from East Asian populations. The Middle East holds enormous internal variation. Indigenous Australians carry their own distinct evolutionary history. Populations across the Americas developed their own patterns after their ancestors arrived there. The labels Black, White, and Asian are useful shorthand in social and historical contexts. Biologically, they don't correspond to how human pigmentation actually varies. Humans see a visible trait, turn it into a category, and attach meaning to it, such as ancestry, status, belonging, and who holds power. That's a social process, layered on top of biology. The biology itself tells a simpler story. Most human genetic variation exists within populations, not between the groups we casually call races. Race still shapes real lives through discrimination, institutions, and unequal access to power and resources. That impact is real, and it has consequences. Two things are true at once. Race carries genuine social weight, and it isn't a set of distinct biological subspecies. Your skin has biology behind it. What society decides that skin means has history behind it. Picture someone with dark skin near the equator and someone with pale skin in Northern Europe. On the surface, they look like they come from entirely different worlds. Trace their family trees back far enough, and the branches converge. Same species, same deep African roots. The pigmentation difference is a small, recent chapter in a much longer evolutionary story. Humans spent most of their history in Africa. Then they moved, met new environments, and adapted through selection, diet, migration, and mixing over thousands of generations. The spectrum of skin color you see today is what that process left behind. Next time you notice someone's skin looks different from yours, one species, one African origin. Thousands of generations spreading across a changing planet, adapting as they went. If this changed how you think about human diversity, hit subscribe. There's a lot more of this story worth telling. Remember to like the video and subscribe.